Welcome. We are live. Okay, welcome to I Can Science That. That's me. And we are joined tonight by someone you've probably seen in the comments of some of my videos, Mittelwelle 531 kilohertz. Or Martin, would you like to introduce yourself a little bit?
Yeah, I think this is necessary to do so. We have a plan for what we do today, and we are both, it seems, interested in physics and how to explain things. And one thing, for example, I think we have in common is that we love to explain things or to debunk things that are plainly wrong and I have a special topic which we will start in about 10 minutes, I think, and I think we can just do a little bit of mutual interviewing of us together. And one question I'd like to ask Matt is in which age his interest in doing little physics experiments like children could do, in which age this started, and whether there was a special area he was interested in.
Okay, good question. When did I first start doing or get into like physics and experiments? Oh, my gosh, as far back as I can remember, I've always been interested in the types of things that I consider perfectly normal, like you make a Cartesian diver, that you take the vinegar and the baking powder and you put it in the little capsule and you put that in the water and it sinks and it floats as the bubbles come out. And you make rockets. We were into model rocketry. Really, it was my older brother made the rockets, but as the little brother, I got to participate. Model rocketry, that was tons of fun. But it really was, I would say, senior year of high school, AP physics. So that would be 12th grade, the last year of high school before you start university. I took the AP physics class and just had a great teacher and a great group of students. We sat in the back row at our table and we were obnoxious, but mostly just having a lot of fun doing physics with the class. And I'd say that's where I really got into it, was AP physics class.
Mm-hmm. And any special topic, or was this just physics, all topics in physics, optics, electricity, or?
Mostly I'd say dynamics or kinematics, I guess what you say, mechanical stuff for the most part. Electronics was very interesting, but it was harder. Frankly, it's harder to study. When you study the mechanics stuff, Newton's laws and such, that always just seemed so easy for me and so just beautiful, just wonderful to see that.
Because if you sum up everything, you must have zero. That is a nice thing. I remember that mostly from the first or second year in university when we covered mechanics, and everything came very natural to me because I liked to play with the construction kits. I don't know how they named in the USA. In Germany, the German firma was the firma Märklin, which produced them. They were from metal strips with holes in it, and you could put screws in it and build many things with moving parts or static thing. And it was intuitively clear for me stability of things, like if you have an angled beam or a T-shaped beam, or so, how they bend and so, and then it got explained to me, and I understood it from the physical viewpoint, and it came very easy to me. And also, I had a good teacher in the school. We were one of the model projects who had a thing. My physics teacher for us bought a thing which later on was available as programmable pocket calculators, but the size was about of a big electric typewriter.
Right.
And it was programmed basically in mathematic formula, and it had a plotter, and I could plot sine curve shapes and so on. And I had the key for the room and could access it in the afternoon and so. And he also forwarded my interest in electronics, and digital electronics were just coming up at that time. And I have because I was curious when this started, I have looked up some early booklets I had. It is from 1969. I don't know if one can see it. Wir experimentieren. No, it's not wir. This is the wir experimentieren. WE. Wir experimentieren. And I was 15 then. I thought I got interested in a little bit earlier. But some things that are very far away, I associate with the wrong time. For example, this is the other one. These are this is the Electroman. This is for kids, construction kit to do electric experiments. And this is the Radio Man. This is what in German is called Funk. It's the English word for spark. And from this, I know that you really can do wireless transmission over a meter or 2 or 3 meter by firing a spark.
And I know that from my car.
and the receiver was built of 2 metal rods and with some small iron parts you get from filing in between as a bridge. And if you do a spark 1 meter or so away, have a coil and break the current so it gets a spark, it really breaks the connection from the metal file. What is this things called which you fall down when
filings.
Iron filings, and they break, and the current through it will break, and the little lamp goes off. So you have a spark here, and 1 meter apart, something electrical happens. And this was one of the introductory experiments to it.
Very cool. Very cool. And then did you get into ham radio at some point? We're guessing from your moniker there.
Yes, I would always have liked to, but it was a little bit too expensive. And also at this time, we would have to learn Morse code, and I'm not so patient if I have to do a lot of exercise with things. And so I also always shied a little bit away from it. And then it turned out, because of my interest in electronics and digital electronics at university, I first started with electrical engineering, but after 6 half years, after 3 years, I decided to change to what was called Datentechnik or technical informatics, which is a mixture of, you can either consider it as kind of electrical engineering with much software, or as kind of informatics with a little bit hardware related. So in the middle between both. And this is the natural interest I typically have, and my customers to which I teach C++ often come from the embedded world. But I really started with developing software in BASIC. That was around 79. This was where my first programming jobs, and I very early came to a Unix lookalike machine on a 6809 processor, which today people probably won't believe that you can have a Unix-like system on a 16-bit processor with about, they had not hand wired. They had constructed from parts around the processor. They had a memory management unit, but built in hardware, not in a chip. That was not available then. And with it, they expanded the 65 kilobyte address range. They could, I think, 0.5 megabyte or so we had typically in these machines. Wow. And the Unix probably, I guess, was the version 6 Unix was used in Australia for teaching operating system design in the late, when has it been, in the early 80s. And I think they rewrote it into 6809 assembly code. and they stripped off some things. Of course, there was no networking at all. Yeah, there's no network drivers and no wireless and so.
Okay.
And but they reduced the permission system a little bit. They had only all and owner. But it was really nice. You had in 65 kilobyte, they had the kernel of a small Unix system and all the data it needed. And the memory management unit allowed then to switch around between processes. The only drawback was when you wrote a C program with bad pointers in it, you crashed everything. Everybody who worked, there was a multi-user system. We had
if you crashed it, you crashed it.
Yeah. And we always want, now I start a C program which is not yet tested, save your files and so. And but it was a nice time, and I learned to work with small resources. And if I look into JavaScript, web programming also, it is so monstrous, everything. And what do you get from it? It's often a poorly designed user interface, and it's horrible sometimes.
I'd say file that under kids today, right? Kids today, they don't know how good they have it, and they never learned, right?
But my parents did this to me also in the 60s. I don't know how good I have it. They went through World War II, and my mother's house, or this was an apartment or a flat in a house with several families, got bombed, and she had to leave the place where she was born with her father. And my father was I think in Russia at this time, but he was lucky enough to got moved to France, and therefore he came back, I think in 49. Not quite sure but before I was born, he was already back, so I didn't grow up without a father. My oldest sister, their first 4 years in her life, she was only together with my mother, and then there were a little bit some problems when my father came back to the family. He was a foreigner to her a little bit, and she, before she was alone with my mother, and then my father came, and then my other older sister, I have two older sisters, my other older sister was born, and she was the favorite girl of my father, and the firstborn not any longer. And 5 years later I came, and they both fell out of favor. Okay, it's very personal. It's all long ago.
Let's do one more question from the chat here. LB Things and Stuff and More says, I'm curious, has the technology improved over the years, like things to help with Morse code?
I think so.
Since then, I mean, the computer you're talking about, I actually learned assembly on a 6800 series as well. But it was assembly on that thing that I couldn't imagine trying to get Unix to run on that. That's a neat trick. Those were ridiculously primitive by today's standards. And as far as Morse code, we can still use Morse code as a fallback when all the technology fails us, but we definitely don't use it anymore as like the primary communication mode anymore.
What I'm thinking about this, maybe this is patented, like many silly things are patented. If we have a small embedded device which has only, say, one button which you can press in certain sequences to reboot or so, and only one LED, why not send out data over the LED with kind of a Morse code which you can receive with a handheld, and it prints on text something on the screen?
Yeah, I've definitely seen some things like that. Some commercial devices even, I think, that you can get that can transmit data via light. And they'll transmit it fast enough with an LED that you can't see the light blinking.
It was before wireless came up. There was an infrared standard communication. I think HP printers had it, for example. But it then was the small powered wireless transmissions nowadays is really perfect.
Yep. Okay. Well, are you ready to start with our main topic of the night?
Yeah. I'm ready to start. I'll just get my notes, but I can reproduce it from memory, I think. It was actually Corey Kell, to whom I could relate very much, because as a child, I always thought later in my life, I will invent big things and I will make discoveries in physics or something. And this was about, I think, age of 7, 10 or so. And my goals then gradually reduced as older as I got. And maybe I think I have 1 or 2 electronic designs which may have been patent worthy if I had worked in a company. But my goals got very low, and sometimes in your life you see a problem which you think that is so easy to solve, and you wonder why nobody has have it solved. And at age 10, I would have thought I'll do it some way. But today, for example, probably the colored sequence or the 3n+1 problem. Does it tell you something?
The 3n+1 problem.
No.
Sounds familiar, but it's not coming to mind.
It's a thing where mathematicians warn other mathematicians to invest too many thoughts into it.
Don't waste your time on it, because it seems simple, but it's impossible.
If you take any number and multiply it by 3 and then add 1, and then you divide it by 2 until it gets an odd number again. For example, if you start with 10, you go to 30, 31. It's not an, start not with an even number, start with an odd number. Say we start with 5, you get 15, 16, 4, 2, 1, and so you drop down to 1. And it is proven only by trying that all sequences finally end in this 1, 3, 4, 2, 1, 3, 4. They come always down to this. And it sounds so easy, and it's a nice thing to think about. And I'm not so big in mathematics that I think I can come up with a solution to it to prove that this will be for each number, no matter how large it is. And that is one of these things. And that is not my goals. But one thing, and this leads to the main topic where I think one might get a little bit famous, is by showing that in a book something is wrong, and all the other authors had copied this without thinking about it. For example, I don't know whether this story made it up to the USA. In Germany, when I was young, eating spinach was said it gives you much iron your body needs. And do you know the backstory about this? This was a typo in a book.
Yes.
Yes, you know this. Okay. Or the other thing, maybe you know this too, the thinning out of the ozone layer could have been detected 3 years earlier if the measurements not had been thrown out as measurement errors. Because someone had said, if it's outside a certain range, our devices don't operate, don't get exact measurements, throw it away. And then some scientists said, this looks strange to me. And then he looked into the code and he saw that the low measurements already were present some years before. And nobody noticed it. And such things, I think, you can get famous with. And this was, Corey, for example, what's wrong with this stuff, he says. And also this one, I think John Mandelbauer, who claims there is no conservation of angular momentum. This is all nonsense. Or before this flat earth thing came up in Germany, we had this Joycelyn Lopez. I think she works in an office somewhere, but she claims Einstein is wrong with relativity. And if you add 2 speeds, you get the sum of 2 speeds, and everything else is nonsense. And he goes to physics forums and arguments there with this, and this is absolutely pointless.
Is that somebody that has like a physics education?
No, I don't think so.
Okay.
I think she... often I notice if it goes against relativity, there is some anti-Semitism behind it.
That could be. I was recently in the comments of one of my videos talking to someone who's actually a geocentrist, not a flat earther. I'm not stupid. I'm not a flat earther, but he's a geocentrist, and argues against special relativity. And I was dumbfounded that there's people, and he's got a great deal of research behind all of that. And he could cite all kinds of things. And I was like, really? People really find special relativity difficult. I remember I found it difficult when I was first introduced to it. I definitely thought that sounded stupid. But as I look it over, it now seems obvious. It just seems so very, very obvious at this point that I'm kind of astounded it took so long for us to figure it out. But I guess I have to remember that at first it seemed weird.
Yeah. Okay. And to our main topic now will be, I'm working at a slideshow which now looks a little bit different as I initially started. Can I share my screen here?
Yes, you should be allowed to share your screen.
Here's the share button. Yes, and I want the. I can only share my main screen, not my second one. It seems. So I have to move it down.
Let me see what happens when they say share screen. It lets you, when you click share screen, it lets you choose your screen.
Okay. I see. Screen sharing is easiest with two monitors. And then comes another screen where I can select one.
If you, at least on mine, at the very bottom.
I see. It's like in most conferencing software. Okay, so it's this one. And
okay, there you go.
Do I have control?
I add it to the screen.
Okay, yeah.
Let me full screen it. So let me do that.
Okay, and this is the current version. And in the initial one, I had this diagram. You will see. I'll not go. This presentation is not our main topic directly. It's a side effect from this one. Okay. And you see here this pulley and the two weights. And on a later slide, I compare buoyancy with something heavier goes down and something lighter goes up. But I'll do it first without this pulley system here. And here the question is if they have a heavier weight and a lighter weight. And now this heavier one is down. But if you imagine both were fixed in an intermediate position, and I ask how fast they accelerate, I ask myself how fast they accelerate. And of course, you have a difference in weight of a quarter of a kilogram, or I know that kilogram is a unit of mass. You can count it in Newton, but the whole mass that gets accelerated is, of course, 2.45. And so the acceleration by the quarter kilogram, I think that is then, I have always difficulties in newtons. This is 10 times as much, I think. No,
about 10, right?
Yeah, you have to, as the accelerating force is the difference between the two, but the mass accelerated is the sum of both.
Yes.
If you calculate how much this accelerates now, and then I went to this where I compare it. Here is it. Here's the heavy one is the top one, and here the lighter one is the bottom one, and I compare these two situations. And I asked myself whether when say something lighter flows up, you have something less dense than water, and it flows up, and the water goes down. They change their position. The water is heavier, so buoyancy is nothing magically special. It's simply the tendency of the heavier thing to go down, and if it forces because it wants to take the place of something lighter, they change places. And at that point, I asked myself, because one mass is going up and the water is going down, shouldn't we have to add these two masses? And the difficulty here is, just a little side note, did you, for about 1.5 years ago, see the series from Jean Carroll, The Biggest Ideas in the Universe?
I don't remember seeing that.
He makes at the very first or second one, he brings this famous round cow or circle.
The spherical cow, and
spherical cow, yes, the
the
spherical
spherical
cow, yes.
cow in a vacuum.
Yeah. And which, of course, you mean you idealize things, even if in reality is not that ideal. You idealize things, and I mean now, not if you consider fluid friction in the fluid or whatever. If you take out all friction here, and then this lighter thing starts to go up with some acceleration, and the heavier goes down. And because two masses are accelerated, the one here, like with the pulley, the one is accelerated up and the other one is accelerated down. If you consider no friction at all, wouldn't we have to add these two masses if we calculate how much it accelerates up?
Very good question.
And this, let me say you one thing. This I thought several days about it, whether it might be such a problem like with the spinach that every physics book only writes this mass has to be considered for the acceleration. And I even asked a person we know very well in the flat Earth community on the debunker side, of course. And also he didn't tell me, he just said it is difficult because of the friction and so on to calculate. Yes, and I want to know from you, is this possibly a thing where we can get a little bit famous by finding out that all our physics books are wrong, which say only the non-fluid mass determines what in the ideal case what the acceleration is?
I would say that would be awesome, but I think you should probably tap the brakes on that Nobel Prize application real quick. I would say, actually, you made a mistake a long time ago. Back when you were doing the pulleys, I don't think you did it correctly.
Okay.
I would, as an engineer, I would approach it by chopping it into smaller pieces and looking at things in isolation individually.
Yeah.
So what I would do with the pulley is I would calculate the tension in the string first.
Okay.
And so we do know that there was 0.05 kilograms more on one side than the other. So what would the tension on the string be, like at initial when they're not accelerating? I would say that there's X force on one side and X force on the other side, and they're both pulling. And so then that would give you the tension force on the string. And then just look at the tension force applied to just one side to see its acceleration. Is that going to work?
I don't feel so, because if I consider two very light weights with a certain difference and two very heavy ones, I have a feeling that the heavy ones will accelerate less.
Yeah, you're right. That's not going to work. Yeah, the tension will be the same on both sides. The accelerations will be the same on both sides. You have to add the forces, and that's going to get you right back where you started. That's true. Okay, so how does that apply on the other side? Because you're right. I look at when I do this, I only look at the force being applied to the mass, and I've never considered the counter acceleration. I've never looked at it as if it were a pulley situation, but I don't think it's a pulley situation. You do have to, the one moves down and the other moves up, and yes, they must move at the same rate.
And they get faster all the time. If the force is the same, they get faster all the time, so there's acceleration.
Well, the way I would look at it, or the way I've always looked at it, is that the the force being applied to the mass is, the weight of the other object, just like as if it were a pulley. Okay, and so, and I've always thought of that in isolation. Why do I not have to consider that it's accelerating that other mass out of the way? Well, I mean, we're saying zero viscosity, right? Which, when we say zero viscosity, we're saying it doesn't cost you anything to move that other mass out of the way. Isn't that what we're saying?
Yeah.
Okay, let's try it this way. If we hung them on weights, right? If you literally hung the water on one weight, and you hung the on the one side of your pulley, and you hung the mass on the other side of the pulley, would that accelerate in the same way under ideal conditions that this situation is? Yeah, wouldn't it?
I think so.
They have to both be in. Oh, wait. Hold on now. Well, no, yeah, you move the center of gravity downward. How much energy has exchanged? That's another way to look at it. And the energy of the water, it has gone down, right? The center of gravity of the water has gone down. And the energy of the brick has gone up. This is an interesting puzzle you've discovered. That is interesting, because you're right. We just always neglect it. But I'm missing something. And I'm sure it'll be obvious after you point it out.
You don't think we are like Corey Kell and have found something which is 45, hilarious 45-degree sector test?
Well, let's take a break from the puzzle for a moment to talk about that topic. I'll put our faces up here. I have learned something that I think maybe Corey Kell hasn't over the years, and that is humility.
Yeah.
To start from the position that I have not overturned all of science, but in fact that I'm the one who has overlooked something. One of my favorite YouTubers is called Potholer54. Are you aware of that channel?
Yeah.
And he frequently says something that amounts to, if I can paraphrase, there's three possibilities. A, like 1,000 years of scientists, they know better and they're tricking me. Or B, 1,000 years of scientists are idiots and none of them is as smart as me. Or C, the past 1,000 years of scientists notice something that I'm overlooking. And just ask yourself, which one is most likely? In your own personal experience, how many times have you just, oh, I didn't see that? And yeah, if you've ever taken any class in college, you know that most of your experience is, oh, that's why I got it wrong. So I start there.
But you also know that sometimes, for example, you are also, like I am in software development and C++ and teach this. And if you look, for example, in the early books on object orientation, you find that all the people seem to copy the same ideas for examples. For 10 years ago, or more than 10 years ago, I wanted to look up a certain limit of specification in the UML. You surely know the Unified Modeling Language. And I got 10 hits in my YouTube search, very different sources, and 7 of them used the same example to explain this. And when I teach something, I always try to think through things myself and come up with my own examples. And for example, I recently wrote a comment on Blue Marble Science channel where he said the maximum number of spherical excess on a sphere can be 270 degrees when you go this North Pole and down equator and up again. And I wrote a comment and said, no, I think it's 540 degrees you can get as maximum spherical excess. And I was right with this. And I often doubt on things others say, and others only hear this and read over this and say it comes from some authority. And this example I shown you here, I found very few books where this was considered, because in practice you don't have this spherical cow.
We're definitely in spherical cow land. It's not something that you could really test.
Yeah, that's.
But I
could this be the problem
I don't think I still don't think it's right, because I had it here a second ago. I'm just sketching over here the pulley, and I think that this is different. Because again, I'm trying to isolate. I've always just isolated the mass and calculated the force acting on it. So the net force acting on it is given by the weight of what it displaces.
This is the difference between the two volumes.
But that is the buoyancy force is the amount it displaces. So it's very much like your pulley situation.
Yeah.
So if I went back and actually calculated the tension, I guarantee you that if I went back and calculated the tension on the string in the pulley situation, I would find the correct answer, because that's what physics says.
Do you think the pulley situation does not accelerate in a way that is different?
I think it does. I think it does, but I would have to then back out and find that the tension, right? You have to be able to cut the string and replace the string with the amount of force that is acting on the string.
Yeah.
And have the situation remain the same, right?
Yeah.
So if we knew exactly how much force was pulling upward on the string, that mass does not know that there's another mass on the other side. It only knows that there's a certain amount of force pulling on that string.
Mm-hmm.
So, I mean, working forwards, you can tell that the tension is, based on what the acceleration of the, of the weights is, right? We can on the pulley one, we can fairly trivially calculate the acceleration that the lighter mass feels, and from that get the force acting on the lighter mass. That's the tension in the cable, right? And that should be the same tension on the opposite side.
Yeah.
Right. Can we do the same thing with the water?
But you have on both sides also the force of gravity,
Right. So the tension in the wire is analogous to the buoyancy force.
No, it's more, I think.
No?
The tension in the wire is
the up force, and gravity is the down force.
Yeah, okay.
Right?
Yeah.
So they seem analogous, at least. I would really very much expect them to work out the same. But yeah, so the buoyancy force is the up force. How much up force is there? So like in this case, is the up force the weight of the heavier weight? No, it is not. I don't think that it is. Because I think
if we start with a situation where both weights are the same, where this is neutrally buoyant, we would have no force at all. And then if we make a very, very tiny difference, we have an accelerating force in the pulley situation, but two masses start to move.
Right.
And in the buoyancy experiment, it's the same.
Is it the same?
Yeah. Okay. I think
I
will. I let you go and think about it, but I lift the cover a little bit that I know where the error is.
Okay.
I had to think 2 days about it.
Give us a clue, because people don't want to wait forever while I figure it out.
Once the weights start to move and the center of gravity starts to shift, where does the one's potential energy go? They lose potential energy in the pulley situation, but the lost potential energy, where is it while it is moving?
You mean it goes into the kinetic energy?
Yes,
right?
yes, yes. It goes into kinetic energy.
And
I leave it at this.
Floating situation, does it not do the same? In the floating situation, the water never gets any potential energy. It doesn't.
It gets whole water does not. But if we consider this this little block here, which I said shifts down, this moves down, and there's definitely there is kinetic energy going on here while this is moving. Well, doesn't.
But not the same amount, is it? Because the way you've drawn the blocks trading places isn't really what happens.
No, there is a flow on the side of it downward, but there is a downward flow of water, and there is an upward move of this yellow block.
Right. And so the yellow block has a velocity that builds up.
Yeah, and the water always must go faster, because the distance per time unit, the yellow block goes up, is also more distance for the water to go down, or isn't it?
I'm going to have to do a quick sketch over here. I'm intuitively feeling, and I would have to work this out, that what happens is a small piece of water moves down. While it's in motion, it's gained some kinetic energy, but then it immediately stops. But the block does not stop. The block keeps going. And so then another piece of water moves down and immediately stops again. And so there's not a sustained buildup of kinetic energy of the water, whereas the block should continue accelerating, continuing to gain energy as it goes upwards. Am I on the right track?
Yeah.
So if you moved it, if you think of it like moving just a tiny amount, then you've got the water has traded potential energy.
Yeah.
But it's now stopped.
Yeah.
That water that moved is now stopped. And so it gave up its potential energy to the brick, to the block.
Yeah, that's right. That's right. That's the way. That's exactly the way that led me to the solution too.
Okay, take it over.
Our spherical cow has gone too far here. We have to assume some in the water flow somewhere the energy must be stored back when the water stops. And if we don't assume any friction or so, and the water comes to rest, it must be fully go back to the block moving up. So we don't need to
bounce it and reflect it back up.
Yeah. That's the answer I found. On my way through it, it was during my last holiday in November. We were in Gran Canaria at a nice finca, because I always like to go to warm areas when it gets cold in Germany. And you live in the near Los Angeles or San Francisco area?
Los Angeles area.
Los Angeles.
Close by
I was in this
Pasadena.
area, I think 5 or 6 years in a row between 1995 and 2000, not always the West Coast, because there was a Unix convention I visited, and I know this area a little bit by driving. And after the convention, I stayed a year and drove with the car. And yeah, well, and when I have no work to do, I often think about problems like this. And this was my problem in Gran Canaria. I think
This is a good one. Yeah.
it took me about a day, because I'm not Corey Carroll. I was sure I'm wrong. I was sure I'm wrong and stopped thinking. But I asked Blue Marble Science in private mail.
How did he do with it?
And he only said it's complicated because of fluid dynamics and so on. I didn't explain to him the theory with the spherical cow, and so that I only was interested in the limits of this. And I try to leave him alone, as I don't want to disturb other people with my ideas too much. I'm not so important in the world that I think I have the right to do this.
Yes.
Okay.
I think I would have gotten it from the energy analysis eventually. Yeah. I also think that you can get it by differentiating the force. That's been done a million times.
Yeah.
Differentiating the force, and then you'll see, I think when you do differentiate the force, you'll see that the difference is that there's a force, the pressure on the bottom as well as on the top.
But the force, I think, is calculated in the same way as in the pulley situation.
Yeah, you'll come up with the same force differential.
Yeah.
When you do, but then when I'm finished with the force differential, I'm going to again take it in isolation and not consider the forces acting on the other thing. The forces acting on the other thing will cause it to move in its way.
And right? It moves, and the kinetic energy is in principle there, but if we assume that the whole fluid is in rest and there are no turbulences and no friction where the energy is given up, the only way to come to rest again is that the fluid that goes down restores all its kinetic energy as an additional upward force, and therefore you need not consider the mass of the moving fluid.
Yes, I concur 100%. LB Things, Stuff and More asks, what forces are acting on these? So in the diagram on the right, we have gravity pulling down, and then we have just the force of buoyancy pushing the block back up. That's it, just gravity. So we're deliberately ignoring viscosity, friction, all of that kind of stuff.
But when we know the fluid is going down and has kinetic energy, and we claim all the fluid below the block is in rest, in total rest, and right. There is no other way to lose the kinetic energy in turbulences, and therefore we need to assume the kinetic energy from the fluid going down goes into the block upward.
Yes, very good.
And
so
therefore,
the energy analysis reveals it. In a way that the force analysis leaves you unclear. Where did the force go?
Yeah. And I made another error when I thought about it. I was a little bit flip-flopping between two positions then when I did this energy analysis. The other thing I said, but it's accelerating all the time. There is always more energy. The fluid always goes faster past the side of the box, the block. The faster it moves up, the more fluid must pass it on its side. And this is also wrong because I changed reference systems.
Right.
This is a typical problem I've seen with many flat earthers. They flip-flop between their reference systems and get totally confused about physics.
Yeah. There's the classic video where we see Brian Mullins, is it?
Yeah.
Does the airplanes thing, and he's got his reference system, and he's He's laid it all out, and then as soon as the airplane takes a turn, you can see his brain just overflow, and just like he just lost track of his reference system, and all of a sudden the reference system is gone, and he's lost 900 miles per hour or whatever it was. Yeah, that's a really slick problem. It's cool.
Okay, this was my motivation to write you after I've seen Corey Kell, and I understood that I'll not be the second Einstein, and but spotting errors in books or in videos here like this 270-degree spherical excess thing is a thing I like to do, and you probably noticed
there are
I do it a
errors
lot.
in books, though. I will definitely point out that you can spot errors in books sometimes.
I did so. I think it was about age 14 or so. In the library, there was a library especially for young people in the where I lived. It aimed also to children and so, or maybe up to 15, 14 or so, something. And there was a book about geometry, and I learned about sine and cosine and so on approximately 1 year, because before it became in math. We covered it in math, in my math class. And there I was 14 years old, and there were some exercises in this book, and there were, I think, about 5 or 6 errors where something was calculated wrong, and I could clearly identify, and it was in a book, and it was the first time I found that a book that might be used in school, it was not a book intended to be used in school, it was for electrical engineers getting in the basics of this. And I showed it to the person, to the woman who led this library, that these things are wrong, we must note this down. And she was a little bit cautious, but I was so convincing that she finally took a pencil and wrote the correct answers I gave her in.
Oh, really?
I must have been really convincing to her. She had obviously she had no idea about trigonometry, because it was a library for children up to 6 years old. From the library, they could read up about my age. And
that's pretty amazing. That is pretty amazing that you managed to convince the librarian to deface a book.
Yeah.
That's
I don't know in which way she did it. It was maybe she wrote it on a piece of paper and glued it in the last page of the book, or so that it was clear. Yeah. Maybe such experiences lead to, for example, Corey Kell, when he goes to a flat Earth conference, of course, everything they say, this man knows the truth, and so, and then it gets a little bit. It was so funny when he said to you, "Am I too technical? Is this too technical to you?" Or when he said, "I have to look into the math." and you exactly. Yeah.
Right. What did you think, by the way? You think some people think that those were signs that he's like a con man or something, he's a fraud. I didn't think that. Did you think that?
I don't see how they can really earn much money with this.
Right.
Maybe the top 6 or 10 of them, maybe Charanism and so on. Maybe I have no idea how much money you can get from YouTube. And I don't know how much you get paid if you give a talk on the Flat Earth conference. But in the area where I work, we don't get paid. I give sometimes talks and conferences. I not even get free hotel for this. 20 years ago,
usually you get admission to the conference.
Yeah. That's all.
Yeah, they'll give you a badge. That's about it.
Yeah. 25 years ago, they paid at least the hotel room, and now it's and I don't see how they get the money.
I've gotten airline flights.
No travel expenses. No. But I have one theory how they can really make money. I have 1 or 2 times put it into a comment. Imagine there is some old person who has no children, but has very much money to give, and he says he invites dozen of people and says, I have an idea, you all now have to believe in flat Earth. And you don't must fall out of character until I die. And then everybody who is still in gets the money to equal parts.
Interesting.
And the only one who dropped out so far was Renji. This is the explanation that would make most sense to me if they don't really believe in it.
I recently, I forgot who I was watching. Maybe somebody knows. I think it was it Creaky that or it was Mr. Sensible that posted some Discord posts from a flat earther that came out as that he was faking the whole time.
Speak truth. What is this?
You know, seek truth, speak truth. He was a believer who switched sides.
Yeah.
So you can get a lot of insight by listening to him. But I think it was Mr. Sensible was debating someone, and somebody really nasty. But ultimately, he admitted that it was all just a joke. And there's somebody that I've been speaking to. I haven't had him online, but on live. But I've been speaking to him for a while now, and over and over, this conversation always goes the same way. It's like he makes a claim, I make sure it's very clear what the claim is, and then I show that the claim is false. And at first he resists, and then he agrees. Yeah, you're right. You know, that's I guess not right. I guess that claim wasn't true. And then he's still a flat earther every time at the end. He's like, yeah, but I'm still flat earther. And he refuses to take down his videos where he makes the false claims. And he said, oh, it would be lying to take it down or something like that. And then recently he said something to me about basically, oh, this doesn't really matter to me. I just like winding you up is what he said. And now I'm wondering if he's even a flat earther at all. I don't know.
Maybe people just like it just for fun to do it. It's probably we cannot imagine because we have different philosophy of life. Also, I have sometimes a very dark humor, or a very I tell things which I don't mean serious, and nobody notices. And the funniest thing was, once in one of my first videos, two people wrote comments, and this video which was not quite clear whether I was arguing for or against flat Earth. And if you only viewed the title and the start of it, you could get the wrong expression. And one commented from the perspective against flat Earth, and one against globe. The one got this wrong, what I said. And both of two went against me in their comment and didn't notice that they were on different sides. It was really funny to read. But compared to the first videos I make, I have now adopted quite a different style, because I like much more like what you do, or flat Earth peer review, or so. This is much more what I like, to find how to explain things in a way everybody can understand.
Yeah, I've definitely used a piece of one of yours in one of my videos. The one of my favorite demonstrations ever of buoyancy, actually, is one of yours. Where you have a water bottle, and you put
I know, a
styrofoam and like a piece of metal or something in a water bottle. You seal the cap, and you show that the styrofoam floats and the metal sinks, and then you just hold it and you spin. You spin around, and then you show, look, the metal goes to the outside and the styrofoam goes to the inside.
Yeah.
It's like
I tried to do this helium balloon in a car experiment in an easier way. By the way, this one, what we have shown here, to give you just a very short preview, not slide by slide of what is to come. I'm currently building this, if I have time to do it, besides the renovation work in the flats I told you. This should be a simple device which shows once things are in free fall, you have there are no forces. There is no force of gravity any longer. And what I propose is to get a small tube in which I only choose a 1.5 volt battery. You can choose AA or AAA. It's probably easier if you have 3 volts, but there are little expensive LEDs which only needs 1.5 volt. They have an internal voltage converter, and they cost about $2 or so, I think. Not very expensive. And you put a spring here so that the battery pushes the spring just a little bit down, so that is no contact here. And when you let this fall, the full spring force, because the force of gravity is in free fall, goes away. Full spring force is available, and it closes the contact. And the LED lids, or if you buy a little buzzer which works with 1.5 volt, you would hear the sound. And this is free fall detector based on household items. But I have the parts here, but I wanted to try it out. Of course, you can let your handy fall, your mobile fall down, yeah. But this is an inexpensive thing, which doesn't hurt if it breaks.
Right. If you do it with the mobile phone, you're going to need to cushion that somehow.
Yeah, and it is difficult to look at it at this moment. And the density tower experiment, I think Ray G50 did. It has the problem that once it has a specific order and there is no force at all, there is not much reason to change this order.
Right.
The density tower then just stays as it is. And this device, because of the spring below, this device would close the contact.
Yes, I agree. I like this idea. If I thought it would convince anybody of anything, it'd be awesome. But what it is fantastic science demonstration for people who are interested in the truth, interested in real science, like that kids can do. You could do this. This could be a cool, science fair project.
And you can put it on its side and show that the light lights if you put it horizontal, and if you accelerate it in one or the other direction, or in one direction, then the light goes out. So you can demonstrate that gravity is in principle an accelerating force. And this is what the rest of the slides I have skipped over are about. And I don't know which I would publish first. Either I make a video from this one or these little experiments which are meant as shorts from only 1 minute, which
I really liked your shorts that you shared with me.
I know.
I like that angle of doing the shorts. And that's something else a friend of mine has urged me to do, and I think maybe I'm going to try and do this summer, is probably create a new channel and call it Dollar Store Science. And so this is the kind of thing that I would be looking to do, is very inexpensive household items, everyday science experiments that, like science fair projects, types of things that, kids and adults with kids could get into and learn science and get excited about doing things that are, real.
This is about this, what I showed you in this experimentieren booklets. We built a computer is on the backside here. That was an interesting project. I remember it. They built it from carton, hard paper. What is it called?
Cardboard? That's a cardboard computer?
Cardboard, yes, from cardboard.
Wow. Is like an adding machine or something?
It's too far away in my memory. I know when it was there, I think these are a little bit like sliders here, and either you roll a ball through it, or I have to see if I have this other booklet there. Yeah, and this was the intent also of these books in this time. Yeah.
Very cool.
And this is also interesting. That is in a rotating ball. That gravity in the center goes down, and if someone steps, oh, I have the camera picture here.
Mm-hmm. Let me make it big. I'll take this one off. So
I can do one thing. Once I have set up my document camera here, I can page through it and can send them to you.
Awesome. That'd be cool.
This is from 1969. If you want,
what you ought to do is make a YouTube video, put it on your channel.
Yeah,
and record it.
I don't know whether I violate any copyrights if I do this on my channel, but I think
from 1960 what?
1969.
A quick check ought to see if they've renewed the copyright on that, but isn't the copyright out after 30 years?
I hope so.
30 years is the standard, isn't it?
Okay. Just one question, if it is not too private, about what is your age?
How old do you think? Let's take a poll from, how old does everybody think I am? Let's see.
I think between 30 and 40, maybe not quite 30.
Not quite 30, okay. And anybody in the chat want to have a go at it? How old do you think I am? Nobody's typing. It's probably stuck. I'm gonna hit refresh.
Me too. Okay.
I dropped out. Am I back?
Yeah, I'm also still
okay.
Here.
I don't see anything in the chat. So, oh, here we go. Real Cygnus says 32, and I Like Turtles says 180. So, darts joke. Okay, and the correct answer is, what year is this? It's 22. I will be turning 52 this year.
Oh, so you are in good shape.
So,
but you are not yet old enough for my idea of a 65 plus years Globers Club.
Oh, is there a 65 plus years Globers Club?
No, I had the idea recently, and Sable Eagle came up with. I asked a little bit funny in a comment. Maybe we should found such a thing where Globers meet, which are above a certain age. And I'm looking for a name, and Sable Eagle, I think it was proposed, a load of old balls.
That's wonderful. Yeah.
And then I thought I go a little bit higher than 65. I choose 66.6 years as the limit.
Yes. Well, and you need to change your frequency too to 666 kilohertz.
No, this 531 has a certain meaning.
What is the meaning of that? Is that the?
It is in Germany. What is in USA or in, I don't know whether it's all English-speaking countries. You name your frequency ranges by the modulation scheme used. You are used to say AM and FM radio.
Right.
And in Germany, the frequency range gave the name, and we have long wave, short wave, medium wave here. And the medium wave range was from 531 kilohertz up to 1600 about. And it is the lowest station on the scale of the old receivers, which is also my logo. And there is a station called Radio Barrow Münster. And Radio Barrow Münster was in Swiss, a station which has used the lowest medium wave frequency. And one can do some other games with this word. I won't expose because it a little bit more leads to who I am. And so when I looked for a name, because my early interest was so much in Funken, in radio, it seemed appropriate. because it is at one side of the scale, it seemed appropriate. And as you can do some word games with the numbers and the letters
That
in
means
this,
something.
which match me in a certain sense, I found it appropriate. But I often now sign my comments with my first name, Martin, because I like to give it a little bit more personal touch.
Right. Yeah, we talked about that earlier. I tell people that my first name is Matt, but I don't want, don't want to fully dox myself. It's not like I'm hiding, but I don't want to expose myself or the people around me to, psychos on the internet.
And if I see the videos of that guy from the Netherlands, I think you know what I'm speaking about. It is in Jam Panda's intro to do you watch Jam Panda Sunday Roast sometimes?
Once in a while.
Yeah, I used to watch it regularly, but now it's starting to get repetitive. But in this, I know the name, but I don't say who this is. In the intro, there is a person I would not like to meet in the mood which he obviously had in this video. I think he has not so much control over him, or he is very well play acting.
Yeah, some people really take it to bizarre extremes.
Yeah,
and maybe it's play acting.
No,
it's really hard to tell. I mean, the whole thing is really hard to tell, and that's something that I'm trying to come to grips with. That I think that's the world we live in now, where it's the post-truth era that we live in now. It's like wrestling. You ever see like wrestling?
Yeah.
On TV, and there's these two guys, and they're throwing chairs at each other and stuff, and obviously very athletic, and what they're doing is very real, but you watch it and you go, everyone knows that's acting, right? That we know that this was all arranged and practiced and scripted, right? But you see the crowd and the people in the stands behaving like it's real, and you sit there and you wonder, they know it's not real, right? Do they know? Did I just out worldwide wrestling? Did I just right?
Yeah. When I saw these wrestling shows the very first time, I think it could well have been during my USA trips and the conventions in the video or in the hotel TV. I really thought for a short while it is real what they do, but then it became so obvious to me that it must be choreographed somehow. And I often, in my mind and sometimes in comment, I compared the flat versus globe earthers to this, and this was really the thing which made me unsubscribe from a lot of channels. And the other thing is, I don't throw names here. There's a group of people which stick together a little bit closer than the rest, and if some of them is wrong, even if some of them is wrong, the others defend him because it's one of them and not one of the others. And everybody can choose his friends as he wants, and but it wasn't interesting so much. Cool Hard Logic's videos that were really unique at this time, and I still love them. But he stopped probably because he noticed he was at the highest point, and he cannot make something better. You know, Cool Hard Logics.
I watched all those. I loved those. I loved them to death. Those were great videos. And yeah, I am curious why he stopped, but I think you're right. I don't think there's anything more to say.
Yeah.
And now the play field has changed. He did those before the big names started doing their thing, right?
Yeah. What I like best from him, which brings a little shift in topic, and I try to not bring it up too much with some others, is the musings on an afterlife. This I think is Cool Hard Logic's best one. Do you know this video?
I'm going to have to go back and rewatch that now.
Yeah, that is what really happens if you go to heaven, and then he calculates how many people die each second on Earth and how many time they could spend with God to be greeted, and that God will probably need some people who replace him, and so, and yeah, it makes the nonsense of all this so obvious. Yeah. And another nice thing which you may not know is the book History of the World in 10.5 chapters.
Don't know that one, no.
Yeah. I bought it for 3 or 4 years ago, and there is one story about dying in it. And I will not spoil it too much, but it is basically about that it is our curiosity which wants why we want to live forever. I say this often to my wife. I say I regret that I cannot see how the world will be in 100 and in 200 and 300 years. And it would suffice to me if I would be woken up for a day or half a day and just to see how we progress. And this is the thing I would regret most in dying. But it makes no sense to live forever, because necessarily everything will start to get repetitive, and that it's not interesting to me any longer.
Have you ever seen it's an American sitcom called The Good Place?
Maybe I have. Is this in an office setting or so with no?
The Good Place. I don't want to spoil it for anyone who hasn't seen it. It's on Netflix. It's Kristen Bell and I'm blanking on the guy from Cheers. Totally. Anyway, the main characters wake up in heaven, so they're in the good place.
Mm-hmm.
And over the course of, I think, 3 or 4 seasons, they explore a lot of philosophy about heaven, how to get into heaven, what is heaven like, all of that kind of stuff. And it's a really good show, pretty funny, but also some really good philosophy actually in there. So I recommend The Good Place.
We don't have Netflix here. My wife is still going mostly with this.
Bobby reminded me who it was. It was Ted Danson is the name that I was blanking on. So Ted Danson and Kristen Bell are the headliners, I guess, in there.
I have not a good memory for actor names. If I see the same actor in several movies, I know that it's the one from this and the one from this movie, but I only can remember a few.
I have a bad memory all over the place.
Yeah, it gets worse if you get older.
Yeah. I just console myself that my memory's always been bad. So
I never like just to memorize things which have no relation to each other. That is why I like physics and math and so much more, because if you forget a little thing, you can reconstruct it from the things around them. Yep. But for example, my history teacher, obviously, maybe because he did this every year or so, he had a very good memory for year numbers. And for a long time, history for me was associate certain events with when did they happen. And that was all. And I find it very much more interesting now, for example, to learn about how several religions developed or so, like Mythwism, zum Beispiel, has many good interviews with it. Oh, I think there goes. Yeah, okay. Just my wife was outside. But I have a nice on-air display here, which I can switch on, because she also works from home. She also is in the software business, but on the complete opposite side from me. She does SAP programming.
Cool. Do you guys, you're in Europe, you probably have plenty of bandwidth that you can both work from home at the same time.
Yeah, until the web-based software gets more demanding. I have 100 megabit connection, but the real is really get about 80 megabit.
18?
80.
Up or down?
Up. Downstream 80, upstream I have measured. I think I get what I should get, 30 megabit upstream.
Yeah, I'm jealous. Right? Yeah.
I thought you were always in such a good position there in the Bay Area.
Well, no, we're in the area I'm in, which is sort of Pasadena. The best I can get here is 100 down and 10 up.
Oh,
but that's quoted, and it doesn't always do that. If all the neighbors are streaming too, then it cuts into our budget, because it's not limited by the plan. It's limited by how much bandwidth we've got here, and we're pretty far from the nearest fiber. So that's
I had a friend which now deceased 1 year ago, who always said they in the USA is so much better and they have so much better bandwidth than we, and he always complained. By the way, this friend, I had two close friends which now sadly both deceased before they got 60, even, or shortly after. And one was in each and every conspiracy. If we would not have gone into flat Earth, but it was 10 years or a little bit more ago. It was in banking system conspiracy and what else? 9/11, of course, and so.
Of course.
And the other one was very grounded. And when I never was pulled over to this conspiracy friend side completely. I always argued against him. But some things, for example, cold fusion. 10 years ago, I thought this is an interesting idea. It would so nice if it were true. And I followed some of the sites there. And the other friend of me always said, no, there was this Italian professor, how was it named? This time there was an Italian one who did demonstrations how he harvested energy, and it probably all was faked. But he claimed he had delivered units to the military even, and but I don't remember his name.
Yeah, there's always fakers out there every couple of years. I remember the cold fusion thing. I was in college, and one of my close friends was into a lot of conspiracies, and he totally bought into the cold fusion thing. And he was also into the 100 miles per gallon club. You ever heard of that? That's probably not in
no. We anyways, we count it otherwise. We count the liters per kilometer. We do the reciprocal of your measurement.
Right. Okay. That probably makes more sense with your numbers. But yeah,
I know what it means to get
the idea is to modify your car using these secret technologies that the oil companies don't want you to know about, to try to improve your mileage.
Yeah.
And he totally believed it, that it all worked.
For me now, the switch is turned when someone mentions conspiracies, that there's a huge conspiracy. My thinking is no, that's not probable. I recently met a guy on the street who wanted to get in the Bürgermeister, mayor here in this small town where I live. Not really, but he said that is so much. How do you call it if people only forward their own followers and let no other one in? Vetternwirtschaft. No. Vetternwirtschaft. If you only collusion or what is this?
Oh, okay. Collusion, conspiracy.
And he said if I sign for this, he only want to show that there are also others, not only those who always get the political positions. and he want to show just there are also other outsiders. And this sounded reasonable to me. And the longer we stood with him on the street, the more he suddenly started conspiracy stuff that not quite that people tried to kill him, but it went into this direction. And the longer I let him talk, the more I felt how the curtain closed for me.
Yeah, I feel the same way. And yeah, if there's any like conspiracy fans out there who watch this and listen, there's some advice for you. Is most people are not interested in that. So if you want to try to convince somebody of something, stay away from the conspiracy talk. Well, actually, there's two ways to go. Actually, if you want to be a convincing, soapbox preacher, there's two ways to go. One, find out who's into conspiracies right off the bat, because if they're not into, they don't want to hear about conspiracy, you're not going to convince them. Just let them go and wait till you get somebody who's ready. And the other one is, if you really want to try to convince somebody, then just talk about something very small. Don't go deep into the psycho stuff of, I call it psycho stuff. The it's all they, and they are controlling all of this. And, once you start talking like that, most of us are just going to be like, okay, thanks, man. I'm going to back away slowly now. All that stuff has a bad name for sure.
On the other hand, I'm sometimes really surprised how people manage to build up a fake business. For example, you surely have heard about Elizabeth Holmes.
Yes, absolutely.
Yes, and even high how was this name, in high political positions, former Secretary of State also, I think, gave her money.
Yeah, she convinced a lot of people.
Yeah. And she, I think, on her trial, she said she still believes in it. If she had more time, she would have managed to. And this
Absolutely.
is
goes. Go ahead.
No, go ahead.
I was just going to say, I think my personal journey through the flat Earth swamp has taught me a lot about humans that I didn't understand before. I think she's sincere. I think she really believes she was going to make it work. I don't think she started off saying, I'm going to rip off a whole bunch of people. I think she started off saying, this is a great idea. And she didn't have the background to know it wouldn't work. And then she went to people who really liked her idea. She told them her idea. She was excited about it, enthused, and she talked a good game. And they didn't know that it couldn't work, but the experts did know. The experts they told her right from the beginning that you can't do that, and this is why. But a great deal of people who didn't know any better got behind this idea that they wanted to be true so badly. They wanted it to be true, and then they got behind it, and then that got away from her. She got to the point where now she was, she needed money to continue the dream, and she started saying things that weren't true. And to you or me, someone who's very grounded in absolutely what is true and what is not is our foundation. That we would never go there, but I think a great number of people out there in the world, I've seen this, I think they can very easily take something that is objectively not true and rationalize it into something that they can say as if they believe it. And I think they live somewhere in the range between truly believing it and knowing that it's a lie. I don't think they completely understand that what they're doing is defrauding customers and lying to their customers. I think there's somewhere in between.
Yeah, could well be. The other thing is, I think that the community people have around them. I'm now more in my thinking to atheists and people who believe in God. I feel it's more the fear they have to leave the community they are in, so they don't think about how silly all these ideas in the Bible are. I now listen each Sunday to Herman Mether, or how he knows, who reads one chapter from the Old Testament and mainly he reads the text and makes some funny remarks in between. And this is hilarious if you think about it, what goes in their holy book. Long stories how you do burnt offerings, and always the same text. If you do a sin offering, blah 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 blah. If you do that and that offering, and then comes exactly the same text, and you have to use a goat without without totally intact. No, nothing that is about to die anyway soon. It's hilarious.
Yeah, it's not a good read. I'm going to say, you hear from time to time, the Bible is the greatest story ever told.
Yeah.
And I'm like, I don't know. Have you read Harry Potter? Because like, the Bible's not a fun read. It's not a great story. There's some good stuff in there, though. If you cherry pick out some of the pieces, you can get some really good stuff out of there. I definitely don't like to, and actually, let me take a moment to get on that. I don't like to combine the ideas of science and atheism as if they are the same thing. I like to say that they're orthogonal. Like science and religion are completely orthogonal. Science is the study of the natural world, of things that are reproducible, testable, right? If it's not falsifiable, it's not science. And so religion is for all the things that are completely untestable. So that they're not science.
Yeah, you can divide it this way. But as soon as someone says, yeah, if you want to have this and that happen, to have to pray for it, that is kind of a proof they claim that exists.
Oh, but it's not going to be a testable claim. It'll never be a testable thing.
To us, it will not be testable, because their answer is, for example, my sister is very religious, yes, and she says, yeah, if I prayed for something, I didn't get it. I later understood why I didn't get it in this moment, because it would have not been good for me.
Exactly, that's right. Yeah.
But she has an unshakable belief in this. But I just wanted to come back once more to our flat Earth friends. What I have noticed, and others have too, is that with time they get more desperate, because also my friend who was so much in conspiracies, he had a little bit, not ruined his life, this is wrong to say, but he had some bad luck. He had made some bad decisions himself. I tried to talk him out of, but it didn't hear to me. And then he waited for the big revolution, so to speak. So the banking system collapses, and then everyone gets a reset, everyone gets a fresh start. And so, and now consider someone who thinks once the truth about the flat Earth is out, everything will be better. And year after year passes and nothing happens. It's much like the second coming of Christ, yeah. And they get more and more bitter by this, and more desperate.
Yep.
And the conspiracy they have to assume behind it must be even bigger each year. The masses don't understand and don't find the truth.
Yeah, and all too often those people slide off the deep end into something that ruins their life, or they get into physical harm for somebody themselves, often themselves. Like, you know, mass suicides of cults is a thing. It's like a whole thing.
But does that really happen so often? I know there have been events in the past years, sometimes I think even 100 people in a row, but is that happening more often than every 10 years or so?
Yeah, you know, it's a good question. Is it happening more today than it used to? I don't think so. I don't think we can support that because, I mean, if you go through history, and look at the suicide cults, like just look up how many cults have undergone like a mass suicide or something. They go back decades and decades. I don't think it's a new phenomenon, even though it seems like it.
By the way, to bring up another interesting topics, recently in German TV, when it was about vaccinations and so, someone showed that about 100 years ago, when the vaccination against smallpox were, the people had exactly the same fears and used mostly the same arguments. And that is, it is not only YouTube and social networks, it is just they build a group and have an opinion and they can't be wrong with this. And the problem is they have to leave the group, and that is what they don't want.
Right. And yeah, I was reading, so I was looking for it again. I've lost it. I can't find my reference now. I was reading a paper on that. We're hardwired as human beings. We're hardwired to be part of our group and to support our group.
Exactly.
It's incredibly difficult in general for a human to turn their back on their group, you know, to turn away from their group and not defend their group. So if your group starts saying the sky is green, it doesn't take long before the average person looks up and sees a green sky. You know, it happens. It's amazing, but that's how we seem to be wired.
Yeah, it's I have forgotten the name. I think someone like Wilson. I have this saying or the things I quote. I have it on my desk. I have a clear thing on the desk on which I can write, and below it I can put notes. And there, E.O. Wilson also, and basically the exact quote is a little bit better worded. We have the emotions of Stone Age people, and we have the institutions of the Middle Ages, and we have the technology of gods, and that is our current problem.
Yeah, I will tell you, I worry about what the future is like. I'm assuming you've read H.G. Wells' Time Machine.
Yeah, I don't remember it too much.
Okay.
I remember more George Orwell, but go on.
I think H.G. Wells was prophetic. I think that in the far future, like now that we're solidly in this post-truth era, I don't think there's any turning back. I think that you can't put that genie back in the bottle. I think just full-on open lying about reality is here to stay, and it doesn't lead to anything good, right? If you base like major political decisions on the fact that you think the earth is flat or something like that, right? We're going to build a new tower and we're not going to take into account the curvature of the earth. The tower is not going to work, right? your technology is going to start to fail you. But I don't see that happening because there's those of us out here who will continue to get, you know, higher education and pursue science and pursue reality. We'll continue making more and better technologies and discoveries. But then there's a whole nother section of the world, a whole group of society that is going to continue to turn their back on that. Yeah. I'm going to put that up here.
But I sometimes think maybe that is our own echo chamber.
We're going to separate. I think we're going to separate more and more into those that know the way things really work and those that say it's not that way. And those who know, right? The thing that I think is going to happen is those who know how things really work will build new technologies, and they'll build the economy around those new technologies, and they're going to get rich. And those who don't know how things really work are just going to be defrauded over and over and lose all of their economic power. And we're going to see an increase in the separation of wealth and a correlation between the understanding of reality and the wealthy, and a lack of understanding of reality and the poor. And it could get pretty extreme, I think.
This shifting of wealth to always fewer people that get more and more rich, and I see too. On the other hand, someone recently said, if you gave a king living 200, 300 years ago the choice to live not below the existing minimum, but in a simple job, in an apartment with heating, and so today, probably he won't go back. Even the poor ones here have, compared to what was 200, 300,000 years ago, have the living style of a king. Yeah,
I agree.
That is the one thing. And the other thing, when I was young, I also was very much worried about the nuclear weapons, and we had the Cuba crisis and these things. And I just calculate when you were born, okay, that was something you not lived through yourself, and I only got it from my parents. And sometimes you don't know what is behind it. And behind the Cuba crisis, obviously, was that the USA had stationed rockets in Turkey, and part of the agreement was that no side wanted to show they draw back because of the other one. And our Chancellor Helmut Schmidt in Germany a long time ago said, don't worry about those things, these are under control. And that is the point where I sometimes think, not in the meaning of a conspiracy, that the people who have the real power are not necessarily the USA president or so, who can have a bad dream and wake up and push the button. There are other mechanisms in place, which for good reasons are not public. And that thing, I think, is really a thing. If you really rise high up in power, you will get these things to know. But also Helmut Schmidt said the problem is the clashes of civilizations. So large groups of people who are convinced, for example, right now are anti-vaxxers, and they make demonstrations, and there are other groups, and these are the things you cannot get under control. And as soon as it is possible to build chemic weapons or so in your kitchen, you cannot build for good an atomic bomb there. But that gets the problem of the future. The clash of civilization, and that is a little bit also what you say, the uneducated masses that cannot have a civil discourse with each other.
Right. Yeah. Yeah, I think that's about right.
Okay, I'm not quite at my time limit, but I think we can come to an end, and maybe we can repeat this one day.
Yeah, this was fun. It was a good talk. I wanted to, as we split up, I wanted to encourage you to maybe make that into a video. Take your little physics problem and put that into a video, maybe complete with some solution analysis. I want to spend some time with it myself, because I'm convinced that if I just work out the forces more carefully, that it'll be pretty obvious. where the mistake
obvious
was
thing,
being made.
the obvious thing is the spherical cow is not appropriate here, as this kinetic energy, which is in both parts in the fluid, it needs to be completely given up if you ignore all the turbulences and friction which calm the turbulences. If you allow, for example, there build huge turbulences built up below in the fluid as kinetic energy, then the calculation may be right, but consider once it comes down, what happens? How stops it? Either it stops by friction on the walls, or it does ever rotating and has kinetic energy, and therefore you needed more force. And there the spherical cow does not apply here.
Yep, I think that's a very cool way of looking at it. Something that I've picked up over the years doing like orbital mechanics is that you should be able to work the problem through force or through energy and get the same answer. If you don't get the same answer, you made a mistake. But often one side or the other is much more difficult to do. That's something I sort of picked up along the way that I would like to try applying to your little problem. So yeah, I think you should make a video out of that. And I think you should also maybe research whether that book that you were showing is still in copyright. Because that's worth a share. Just, maybe not the entire thing, but some highlights out of it. It's pretty amazing that you have that.
Okay, so Matt, then I think we end it here. And if you have an idea or want something to share, I have several videos in the pipeline, but I have also other interests, and I'm beyond the age of retirement, but I love to teach the courses I teach, and also in this, if you want to share something which is not to such of interest to a big group, regarding the C++ also, we can also. I'd also love to talk with you but I think your students are at the complete other edge of mine, because I also do work as coach in companies, for example, which transfer their software from C to C++, and so. And I think you have students which are right at the beginning of programming.
Yes, some of my students are brand new beginners, but most of my students are juniors, seniors.
That doesn't tell me so much. What is
junior,
senior? What is this about?
So in a 4-year program, we go freshman, sophomore, junior, senior. So
okay.
So most of my students are 3rd and 4th years.
Okay.
And I actually have some graduate students as well. A handful of those. But once in a while, I deal with the 1st-year university students. Yeah, they're fun because actually most of the 1st year that I teach are not engineers. So teaching programming to non-engineers is sort of a different kind of an animal.
Yeah. I typically have customers who have many years of experience in C, typically, if they go to C++. And recently I had a course where, and then new C, but it was entry-level C++. And you must slow down yourself a little bit and not try to tell them everything which is interesting.
Yeah, for sure.
What I found is I experienced this the first time when I was a student myself, and we learned the programming language PL1. And PL1 is from IBM. It was in the time I started with Algol, and then Pascal, and then came assembler, and then PL1. And PL1 has a remote resemblance to C because it uses the same comment mechanism and some other things. For example, that the main program is called main. You had a subroutine, and after the subroutine you wrote options main, and this was the subroutine which started the whole thing. And there were other interesting things in PL1, but maybe I had a bad professor at the university. I sat there and I thought, I understand nothing about this, nothing. And I doubted that it was the right decision to go information technology, because Pascal was relatively easy. Algol was a little bit more different, but also okay. And then somehow I found a book which explained it differently. And after 3 weeks, I thought, why did I ever doubt about this? Why didn't I understand this? This is so clear. And I had the same experience with the C++98 standard, and then with C++11. And I have not yet looked really in C++20. I know what's coming up, but currently I can have the feeling they make the language too complicated to comprehend for other people than who do it all their life.
Yeah, we don't actively teach. I don't think we're actively teach. I don't actively teach anything past 11. Actually, I don't think. I don't think you need to introduce it. It's for advanced stuff.
Okay, but if you make a cut between C++98 and 11, that's okay. But I would not recommend to stop at 11, because things in C++14 get a little bit more smoothed out.
I might be using 14 and not even realizing it at this point.
Yeah, I think
that happens from time to time.
Yeah,
I mean, like literally just today, I had an old piece of software that no longer compiles, and
that is very rare.
And I was baffled by it. It turns out it was Microsoft's compiler was non-compliant. But
this was a famous problem with the loop variables that are still valid outside the loop. That was the thing that Microsoft did wrong.
That's super old. This one was a template class that inherits from a template base class. And I did not know this. It was non-compliant that you could then access the members of the base class just directly. Apparently you cannot. And
okay, like, that may have been compiler dependent. This is
it was
more advanced.
We spent all day on it. Actually, my grad student spent a week on it before I finally sat down with him to help him with it. And we found out that no, it's not compliant. So I'm still constantly using things that I don't know where it came into the language.
I recently found also one thing I have still to explore a little bit deeper, which I wasn't aware of, which surprised me. So yeah, okay, but if you want to make switches, now you go to that level of standard, or that level. C++14 is a rational choice, because the background story of C++11 is that they wanted to really finish the standard, and they wanted to do it in 08, in 09, in 10, and finally got 11. And that was also the reason, because Strausstrup was a little bit more angry, because he had developed this concept thing for C++11, and he said, "But I need 4 weeks to get away the rough edges." And the committee said no.
I said, "No, you can't."
He was not used to this as original inventor of the language. That they say no to him. He said, "No, we want to have our deadline finally." And there later I noticed that a number of things in C++11 have certain limits, which I thought, why put they these in? And I think they simply came to the point where they got the wording right. That is they use a special clear language in the standards document, and there must be volunteers to describe this. And there were some things which I thought, why didn't they do it this way? This would be much more general. And this came in C++14. And I think they deliberately said, now, final, what we have not put in words until now does not go in C++11. We can do this 3 years later. And since then, they switched to a 3-year sequence of new standards. And first they said they wouldn't do a little bit of an interleave, that have a standard like C++11 and a clean up standard like 14 and new features in 17 and clean up later. But this is not that clear scheme any longer. And now they have, for example, new library functionality they put into an experimental workspace, so that you can try it with one language standard, but you know what you take from experimental may require some changes once it becomes final. And this is, I think, quite a good style. But
okay,
it is a complicated language.
Because we have to check our own biases, right? Are you sure it's not just because we're old, right? When you say like the C++ 14 standard is good, but the 20 standard, nah.
Yeah, I think if I have really looked into it, there comes a point where I either don't want any longer to work in that area, but if I do, I think it's easy stuff.
Yeah, because I definitely see that in myself, because I may not look it, but I'm pretty old, and in my history, I'm an assembly programmer, right? And so I just want my C. I want my C because it gives me access to my assembly instructions without having to write assembly. And then, okay, I'll go into the C++. I was resistant to C++ because it took me further away from the machine. Each time I take a step further away from the machine, I'm resistant. And I know it's just because I'm old, but...
yeah, okay, I need to shut down now so that I can keep my time frame. But finally, if you think I'm in the Caribbean or so, this is a real
obviously
tree here. I have not a virtual background. This is all real. No, it's only real to the next meter. There's a photo, a big photo on the wall, but I don't like these artificial backgrounds. I see you have one from Planet of the Apes.
Yeah. Yeah, I've been using the Planet of the Apes one. I'm feeling that lately. Feeling that vibe. All right, it's been great talking to you.
Yeah, same for me, and I hope we can repeat this.
Yeah,
not in a regular schedule at some time in the future.
Looking forward to new videos from you too.
Okay, me too. Bye, Matt.
Okay, bye. See you, everybody. Bye.